Okay, so this is the last thing we're going to learn with matrices here in this unit. It's going to be solving systems using matrices. So when you look at what I've got here, this is a system of equations. A system of equations just means there's two or more. And so we can solve this a lot of different ways. In fact, we've already seen how to solve this a number of ways already this year at the beginning. We looked at substitution, we looked at elimination, we looked at graphing. Those are all different algebraic methods that we have for solving the equation. And one thing that we had never looked at because we hadn't used matrices before was how to solve a system of equations with a matrix. And it's really interesting how it works. It's probably not something that if you were doing it by hand you would find to be quicker than any of those other three methods. But it is an interesting application of matrices. And one thing to remember is that we do have graphing calculators where we can put matrices in there and they're programmed to do operations with matrices. And so once we learn how it works by hand, you can start doing them on the calculator with matrices, and then it really does become beneficial over those other methods. You can solve it in a matter of seconds with a calculator once you understand how the matrices work. So that's what we're going to look at here. And so I'm just going to start out by, first of all, solving this by elimination just to see what the answers are. And then we're going to kind of put those over here to the side, and we're going to see if we can't get those exact same answers using what we know about matrices. And so, again, if I were going to solve this system with elimination, I could subtract because I know that y minus y is 0y, and that would be 1x minus 2x is negative 1x, and 8 minus 1 is 7. So if negative x equals 7, technically I would be dividing by negative 1 here. X equals negative 7. And then if I plug that back in, I'll plug it into the first equation because that's a little bit easier. If x is negative 7, then y must be 15. So I know that the solution to the equation is negative 7, 15. And just to recall what that means, basically if we were to graph, these are both linear equations, if we were to graph these equations, we would see that at negative 7 and 15, I didn't even count that, we're assuming somewhere right in there. At negative 7, 15, that's where these two lines would cross, okay? And so we're finding the one answer that would solve both equations at the same time, and that is x is negative 7, y is 15. And so we know the answers. Now we want to find those exact same answers using matrices as our method for solving. And again, not necessarily because by hand would be faster, but because once we learn how it works and see that by hand, then you could use the calculator features to get that same answer without any of the work and a lot faster. And so here's basically how it works, is we're going to start by taking all the coefficients, so the 1, the 2, and the 1, and converting that into what we call a coefficient matrix. Not very creative on the names, it's a coefficient matrix because it's created by coefficients. And then next we have a variable matrix, which, if you hopefully can guess, is because it's the variables. And then finally we have a constant matrix because it's made up of the constants. And so this is the foundation of solving a system of equations with matrices. Is we've got the variable matrix, the coefficient matrix times the variable matrix equals the constant matrix. And if you say, well, how are you allowed to do that? Well, think about what we're actually saying. We're saying that this times this equals that. And if we know anything about solving, or by multiplying matrices, let's ignore this for a second. I know that multiplication means that we're taking a 2 by 2 and a 2 by 1, which is possible. The result is a 2 by 1. And if I do a 2 by 1, I need to take this row, this column first row, first column for this. That would be 1 times x plus 1 times y. You can't add together 1x and 1y, so you just leave it 1x plus 1y. And then to get down here, that would be the second row in the first column. That would be 2 times x plus 1 times y. And again, you can't combine those either, so it just stays 2x plus 1y. And remember, we're saying that this multiplication equals this. Well, that's what we already had up here. This matrix equals this matrix. That means that 1x plus 1y equals 8. That's equation number 1. And 2x plus 1y equals 1. That's equation number 2. So all that to say, yes, we can write it like this because it's saying the exact same thing. All right, so we are saying these two equations can be written like this with matrices, and it's still telling us the same thing. And so my question is, how do I get the variables by itself? Because anytime you solve an equation, the goal is to get the variable by itself, even if we have something simple like this. The goal would be to get everything else away, and you know you're finished when you've got the variable all alone, x equals 4. So how do we get the variable by itself when it's in matrices? Well, normally you would say, well, since we have multiplication, the opposite of multiplication is division. The only problem is that you can't divide matrices, and so as easy as it sounds to just say, well, just divide that matrix and then you've got the variables by themselves, we can't do that. So remember that we learned that since we can't divide, we have to multiply by the inverse. Think about it like with fractions. For example, if you want to get rid of 2/3, if you've got 2/3 x equals 8. To get rid of 2/3, you multiply by the inverse, which in this case would be the reciprocal here. Those would cancel, and you're left with x equals 12. Okay, well, we're going to do the same thing. We're going to multiply by the inverse. And so the question is, what is the inverse of this matrix that we need to get rid of? So I'm just going to come over here to the side, and I'm going to figure out what the inverse of this matrix is. Now there's a formula for inverse. Remember, it's 1 over the determinant, and then we scramble up the numbers in our matrix, multiply, we get our inverse. So the determinant, first of all, is 1 minus 2. 1 minus 2 is -1, so the determinant here would be -1. So basically we're going to be multiplying or dividing by -1. So now we start moving things around. So my D and my A switch spots, which doesn't really matter because they're the same number anyway. And then my B and my C change signs. So B is going to become -1 and C is going to become -2. So all of these numbers now get multiplied by -1 or divided by -1, however you want to look at it. And so my inverse is -1, +1, +2, -1. This is the inverse of that. So if I multiply by the inverse of this, those will in effect cancel out, and I'll show you exactly what I mean by that in a minute. So I'm going to multiply the inverse matrix here. Now remember, in any equation, if you multiply on one side, you have to multiply on the other. And another thing to remember is that with multiplication, it's important about the order. Multiplying this times this isn't necessarily the same as if I multiply the other way because it's based on rows and columns. So if I'm going to put this matrix first here, I need to put that same matrix first on this side as well. Alright, so now I'm saying that these two matrices are inverses, and we talked about how inverses of matrices basically will multiply together to get the identity matrix, which is 1, 0, 0, 1. So if I were to multiply these together by hand, which I wouldn't recommend you doing it by hand, if you know their inverses, you should know the result, but just to show you, by hand, I get row 1, row 2, column 1, column 2. So if I'm here, I need row 1 and column 1. So -1 plus 2, -1 plus 2 is 1. Row 1, column 2. -1, +1 is 0. Row 2, column 1. 2 minus 2 is 0. And then last one's 2 minus 1 is 1. So multiplying these rows and columns together, I get this matrix of 1, 0, 0, 1. And then if I multiply by x, y, again, basically what I'm getting, now with this one, I've got 1 times x is x, and 0 times y is 0. So x plus 0 is just x, and then 0 times x is 0, 1 times y is y, so 0 plus y is y. So again, long story short, basically what happens when you multiply by an inverse, and now you wouldn't actually do all this work if you were doing it on your own. You would understand that inverses cancel each other out, but this is what I'm saying by cancel each other out. These multiply to be the identity matrix. An identity matrix, by definition, will keep the identity of what is being multiplied by. So this identity matrix keeps xy as xy. And so the left side of my equation basically just all cancels out, and I'm left with xy equals whatever this is. So really, all I'm doing is multiplying over here. So again, rows by columns. So I get negative 1 times 8 is negative 8, and 1 times 1 is 1. Negative 8 plus 1 is negative 7. And then 2 times 8 is 16. Negative 1 times 1 is negative 1. 16 minus 1 is 15. And so basically, I get matrix xy is equal to negative 7 and 15. So by correlating the matching or the corresponding parts here, I see that x must be negative 7, and I see that y must be 15, which if I look back up to what I had by solving by elimination, I see negative 7 and 15. So it worked. Now, again, like I told you from the very beginning, I am not trying to tell you that this is better or faster than substitution or elimination. However, once you see that it works, the fact that you could then maybe do this with the calculator would potentially be faster and easier than any of those other methods. So we learn it by hand so that we see why it works and how it works. And once we see why and how it works, then we can start doing it without the calculator. So just for one more example, let's look at one more together. And let me pull up another example that I know works. All right, so let's do another one by hand, and then I'm going to show you how to do this on the calculator. All right, so basically, again, take your coefficients, 1x, 1y, 2x, 3y, and then take your variables, and then take your constants, and create a matrix equation. Now from here, remember the whole goal is that we need to multiply by the inverse to get this gone, so that x and y will be by itself. This has to go away so that x and y are by themselves. Okay? So to make this go away, I need to figure out what its inverse actually is. So I need to very quickly over here calculate the inverse. That's 1 over the determinant. So the determinant would be 3 minus 2. 3 minus 2, that's easy, that's 1. So I'm dividing by 1, which means the scrambled matrix isn't going to change. And then remember, when I scramble it up, D and A switch places, so 3 comes up here, the 1 comes down here. And then B and C switch signs. So negative 1 and negative 2. So if I'm dividing everything by 1, that means none of these are actually changing. So this matrix is the inverse of this matrix. So then I can write inverse matrix multiplied by original matrix. And remember, if you multiply it on one side, you have to multiply it on the other. And with matrices, it does matter what order you multiply in. That doesn't normally matter with regular multiplication, but with matrix multiplication, it does. So it has to go on this side. Now, here's where I'm going to shorten what I did the first time. Rather than prove to you that this cancels out, I'm just going to cross it out. Okay? So I know that if I multiply these together, I'm going to get 1, 0, 0, 1. And I know that if I multiply 1, 0, 0, 1 by xy, I'm going to get xy. So rather than do all that work, I'm just going to cancel them out and say that I have matrix xy. And so then my answer is going to be, let me make that a better 9. My answer is going to be whatever I get over here, which is simple 2 by 1. So 3 times 4 is 12. Negative 1 times 9 is negative 9. 12 minus 9 is 3. And then negative 2 times 4 is negative 8. and 1 times 9 is 9, negative 8 plus 9 is 1. So I know that x must be 3, y must be 1. Okay? So, let's talk about what we actually did. What we did was we took a matrix, we'll call it matrix A. So we'll call this matrix A. We took matrix A and we multiplied matrix A by its inverse. Now the inverse symbol is that right there. So basically we took matrix A's inverse and we multiplied it by matrix A because we knew that they would cancel. Okay? Now on the other side, we took that same inverse matrix and we multiplied it by what I'll call matrix B up here. Okay? And that got me my solution. So I know that these will cancel and that x, y is just going to equal basically the inverse of this matrix times that matrix. And so when you actually look and see what's happening and you think about how you could do this quickly with the calculator, all you really have to do is set it up and then say, okay, so to get my answer, to get x, y, I'm simply going to multiply the inverse of this matrix by that matrix. And once you realize that, you can do it on the calculator very quickly. So let's look at that. So clear, just make sure there's nothing in there. All right, so if I put in matrix A into the calculator, it's a 2 by 2. And then I put in matrix B into the calculator, it's a 2 by 1, 4, 9. Basically, like I said, to get my answer, all that's happening is I'm multiplying the inverse of matrix A, which was this, by matrix B. And so I can tell my calculator to do all of that. I can say multiply the inverse of A, which is this symbol right here, multiply the inverse of A times B. And if I do that, there's my 3 and my 1. There's my answer. Now tell me that's not faster than pretty much any other method we looked at. You put in two matrices, you multiply the inverse times B, there's your answer. Okay? And if that wasn't good enough, there's actually even another way that you can put this on the calculator that's, in my opinion, maybe even easier than that. There's another strategic way to use matrices to solve, which I'm not going to get into the details of for this, but if you go to the math button, there's this thing called RREF. It stands for reduced row echelon form, and basically what RREF does is it uses a series of rules that to solve matrices called augmented matrices, and it slowly works its way like a puzzle to get the answer. Now the calculator does all that puzzle for you. All you do is put the matrix in the calculator. So for this one, and I'll put it into C down here just so to keep the other ones in there, what you do is you put all three numbers, the 1, and the 4, and the 2, the 3, and the 9, all three numbers in each equation you put into a single matrix. And then we use this little reduced row echelon form, and we let the calculator, that was matrix C that I just did, we'll let the calculator do all that stuff that I'm not even going to get into. And again, long story short, basically, it gives you this right here, which you'll notice these last numbers are the same numbers we see here. This is the x position, this is the y position. So we're saying that 1x is equal, and no y's are equal to 3. So 1x is equal to 3, and no x's, so 1y is equal to 1. So we're saying x is equal to 3 and y is equal to 1. You get the exact same answer, either one of these. So there's two different ways on the calculator screen at one time that are both faster than anything that we've looked at before. And so, see if I can get one more example here. I'll tell you what, let's just get one example from the homework and we'll go from there. So the first example on your homework is this one. All right, so if I wanted to find the answers for this one quickly, again, basically I'm going to make this matrix be A, those are the coefficients. I'm going to make this matrix be B. And remember, the way that we learned was if we multiply the inverse of A times B, that's going to get the variables by themselves if I were to write that into an equation. So I'll go ahead and put it here just so we can see it again. All right, so if I want to get x and y by itself, I need to get matrix A over here. To do that, I multiply by the inverse. So I need the inverse of A multiplied by B, and that's going to cancel out over here. X and y are going to be by itself. So I can put in my calculator. Let me edit a 2 by 2. There's matrix A. And let me edit a 2 by 1. There's matrix B. So if I tell my calculator matrix A's inverse times matrix B, it'll tell me -1 and 2, which means that x and y are equal to -1 and 2, or x is equal to -1, y is equal to 2. You could also write it as a coordinate like that. That's your answer. Okay. So as far as the homework goes, you've got, how many problems on there? 10 problems. I want the first 2, so this one included. I want the first 2, I want you to go ahead and work it by hand. Show me, not the overdone steps, but show me this right here. Show me that you know how to set it up, find the inverse, multiply by the inverse. You don't have to prove that they cancel, you can just cancel them. And go ahead and get me your actual solutions with multiplication. So go ahead and find the inverse by hand, go ahead and multiply by hand to get me the answers on the first 2, just like what I have here. Once you've done that for the first 2, for the rest of them, all you have to do is write the equation down, put them in the calculator, and then write me an answer. Okay? So after the first 2, write the equation, put it in the calculator, give me an answer. That way I know that you can do it the efficient way. Because at the end of the day, learning how to use these is all about efficiency. So I want you to prove that you understand how it works. Once you've proved you understand how it works with the first couple, then I am fine with you showing me efficiency and showing me how to just get the answers with a calculator so you can get the speed down. That really makes matrices valuable. Okay, once we are finished with this, on Thursday and Friday we will look at how to use this with encryption and how inverses with matrices can be done with encryption to encode messages. So we're going to try to have a little bit of fun with that the next couple days after this. So if you will finish up that sheet today, we'll be ready to go with something a little bit hopefully more fun and interesting the next couple days.